For the last part of Chapter 13, Section 1, we need to talk about electrolytes. Lots of times people talk about sports drinks and so forth being great because they have electrolytes. Well, what are electrolytes? Well, they are things that when they dissolve or are ionized in water, they conduct electricity. That's what they do. So anything that conducts electricity when put into water is an electrolyte. Now, is that good for you? Well, maybe, maybe not. Let's find out. First of all, a famous strong electrolyte would be like salt. Sodium chloride in water completely ionizes, so there's lots of ions there to conduct electric current, and so it's a strong electrolyte. Well, not everything is a strong electrolyte. There are some things we call weak electrolytes. Weak electrolytes are things that only partially ionize, and you'll notice that on this equation, the arrows go back and forth because it's a reversible reaction. In fact, it would rather be in this form, or in this case, this form. This is acetic acid, this is hydrofluoric acid. And the acetic acid would rather be in the molecular form rather than the ionic form, and these arrows go back and forth. You might notice on the page before, here we have hydrochloric acid being formed, and notice the arrow is only one direction. That's because it is a strong electrolyte. Just a reminder that we get the hydronium ion out of the deal. The same reaction, this time they're just showing it with the hydronium ion as a product, and this is a strong electrolyte. The arrow is going one direction. This guy is a strong acid, whereas these two are weak acids, and they are weak electrolytes. There's one other category. I wish they would have bolded it or highlighted it, but there's a non-electrolyte. These things do not produce any ions in solution. Famous example, sugar. And your section here has this great picture. Here's sugar. We'll come back to him in a second. Again, starting with sodium chloride. Sodium, here's the ion surrounded by water molecules. Notice that the oxygen is pointed towards the sodium ion because the positive sodium attracts the negative part of the water molecule. Down here, chlorine has the water molecule, the hydrogens, which are positive, attracted to the negative chlorine and is surrounded that ion with, that's how the dissolving process works. And all the pieces in here are dissolved. There's none that are not dissolved, so it is a strong electrolyte. Over here we have the hydrogen fluoride, and it would rather stay as a molecule. Maybe you can't see that, but that's the fluoride and that's the hydrogen ion, atom. And here is a fluoride ion because some of them will dissolve. Notice that the ion is bigger because he's got that extra electron. And over here is another non-dissolved hydrogen fluoride. So this is a weak electrolyte because some are ionized, but others are not. Poor conductor of electricity. Then lastly, sugar. And there's many different sugars, but sugar will not be broken apart when it dissolves in water. It rather gets surrounded by the also polar water molecules because sugar is polar, and it gets surrounded by the water molecules. That's why it dissolves, but it does not form ions. Therefore, it is a poor or not a conductor, and we call that a non-electrolyte. So, is a sports drink good for you? If you look on the label, you'll find that most have salt in them. So would that be an electrolyte? Yeah. Do you need salt in your body? Yes. How much? Well, too much is no good, so you do need some. And do you need sugar? Yeah. So most sports drinks are made out of sodium chloride and maybe some other salts as well as some sugar. And when you drink it, you feel a little energized. Is it the best way to energize for you? No. This gives you quick energy, as I describe it, like putting a piece of paper on a fire, burns bright for a moment and then it goes out. Athletes are much better served by eating before their sports events carbohydrates, and those will burn more like putting a log on the fire, long and steady and hot. All right, that concludes our section of Chapter 13, Section 1.